Hi, I hope you're well. I hope your classes have been going as well as they can in this online format. In our class, we're coming up on the time when we need to have a test over Chapter 9, and I'll be in touch with you soon about how that's going to work. But this video is to review Chapter 9. Now, on Canvas, at the bottom of the daily lessons for Chapter 9 module, I do have posted the Chapter 9 review sheet with a bunch of review problems. And if we were meeting in person, I'd spend a day or two in class going over these problems with you, reminding you or reviewing how to do them. So instead, I'm making this video to go through how to do the review problems. But before you watch me do them or explain how to do them, I would recommend that you try working them yourself. You can't learn math nearly as well from just watching somebody else do it or listen to somebody else explain how to do it as you can from actually doing it yourself and getting the practice in working things out for yourself. That's what really makes it sink into your mind. So I would recommend that you try working through the problems on the review sheet before you watch me explain how to do them. And one way to do that would just be to try working through all the problems and then come back and watch this video. Or another way would be to try doing it one problem at a time. Work through the first problem or decide what you think the answer should be, then watch what I come up with, and then pause the video and go on to the next problem. So if you need to pause to try working at least the first problem before I talk about how to do it, go ahead and do that. I'll wait here. Now this is what you're looking at on screen is my answers. So what's in black is the original problem. What's in red is what you would write down for your final answer if this was something I was asking you to do. And then if there are in-between steps or work that I need to show you about how to get from the problem to the final answer, I'll try to show those in blue. So number one, -1 is less than or equal to 1/2 x minus 3 is less than or equal to 4. So this is one of those compound three-sided inequalities. Something is less than or equal to something else is less than or equal to something. What we want is to end up with just x by itself in the middle, in between two numbers. So to get there, we have to solve this by doing the same thing to all three sides of the inequality. So I want to end up with just x in the middle. Right now we have 1/2 x minus 3 in the middle. So I'll get rid of the minus 3 by adding plus 3. And I have to do that to all three sides. So -1 plus 3 gives me 2. Sorry, I was going to try to do that in blue. 2. They're going to let me make it blue. There. 2. And then in the middle, -1/2 x minus 3 plus 3 is just the 1/2 x. And then the 4 plus 3 is 7. So now we have 2 is less than or equal to 1/2 x is less than or equal to 7. And now to go from 1/2 x to x, we undo the 1/2 by multiplying by 2, because 2 times 1/2 times x would just be 1x. So all three sides get multiplied by 2. 2 times 2 is 4. 2 times 1/2 x is x. And 2 times 7 is 14. So x is between 4 and 14. It's greater than or equal to 4, and it's less than or equal to 14. This is how that looks on the number line. I use these square brackets by the 4 and the 14 because they are included. X can be equal to 4, and it can be equal to 14. And then the interval notation also has square brackets, starts at 4, goes up to 14. Number 2, x plus 4 is greater than 6, or x plus 4 is less than 0. So in each part, we want to get x by itself. So if I subtract 4 on both sides, here I get x is greater than, and then 6 minus 4 is 2. Here I get x is less than, and then 0 minus 4 would be negative 4. So it says x is greater than 2, or x is less than negative 4. The or means you can be in one part or the other of that solution set. So this is what it looks like on the number line. And when I write the interval notation, it's going to be in two separate pieces. The piece over here starts at 2 and goes up to infinity. And the piece here kind of starts at negative infinity and goes up to negative 4. So it's the interval from 2 to infinity union or together with the interval from negative infinity to negative 4. X is less than 9 unless x is greater than or equal to 4. There's nothing really to solve here. These already have x by itself on one side. We just have to interpret it and show what it looks like on the graph and in interval notation. For x to be less than 9, that would be all the numbers on the left or small side of 9. For x to be greater than or equal to 4, that would be all the numbers to the right, the big side of 4. The word and means that both of those things have to be true. X has to be less than 9, and it has to be greater than or equal to 4. So we wouldn't include numbers like 2. 2 is less than 9, but it's not greater than or equal to 4. We wouldn't include numbers like 10. 10 is not less than 9, even though it is greater than or equal to 4. But we would include all the numbers in between, like 6, for example. 6 is less than 9, and it's greater than or equal to 4. So this is the interval from 4 to 9. And do you see why I have the square bracket by the 4, but the round parenthesis by the 9? Because x could equal 4. We are including the 4, but we're not including the 9. X can't be equal to 9. So this is the interval from 4 to 9, including the 4, not including the 9. Number 4 is like it, but it has the word or instead of the word and. X is less than 9, or x is greater than or equal to 4. So that means we have all the numbers that are less than 9 together with all the numbers that are greater than or equal to 4. And together that makes up the whole number line. X can be anything because you can pick any number at all, and it's going to be either less than 9 or it's going to be greater than or equal to 4. So here the solution is everything from negative infinity to infinity. So notice how and is more restrictive than or. For and, we just want the overlap. For or, we want everything that's in one or the other or both. Here's another and in number 5. X is less than 5 and x is less than 1. The and is more restrictive than the or. We just want the overlap. We just want the numbers that are both less than 5 and less than 1. If you're just less than 5 without being less than 1, you're not included. So these are the numbers. All of these numbers are both less than 5 and they're all less than 1. So it's the interval from negative infinity to 1. X is less than 5 or x is less than 1 looks like this. Now we're including all of these numbers that are less than 5. Even though they're not less than 1, you just have to be one or the other if the word or is there. So these are all the numbers that are either less than 5 or less than 1. And this is the interval from negative infinity to 5. X is greater than 5 and x is less than 1 has no solution. All the numbers that are greater than 5 would be over here on the right. All the numbers that are less than 1 would be over here on the left, and there is no overlap. So there are no numbers that are both greater than 5 and less than 1. X is less than 5 or x is greater than 1. Here are all the numbers that are less than 5. Here are all the numbers that are greater than 1. Didn't we just do something like this? Well, sort of. Every number is either less than 5 or greater than 1. Okay, now we have some absolute value equations to solve. Step 1, if it isn't already that way, get the absolute value part by itself on one side of the equation. Then on the other side, you should have just a number. And if it's just a negative number, then there's no solution to the equation. But if it's a positive number, there's going to be two solutions. So to find what those are, you would set it up in two separate equations. One where the thing inside the absolute value bars is equal to the positive number, or the other one where the expression inside the absolute value bars is equal to the negative of that number. So here that would be 2x minus 3 equals 7, or 2x minus 3 equals negative 7. Then we have to finish solving each of those equations. So if I add 3 to both sides, 2x equals 10. Or in the other equation, if I add 3 to both sides, 2x equals negative 4, because a negative 7 plus a positive 3 is a negative 4. Then finish solving by dividing both sides by 2, and we get x equals 5 or x equals negative 2. So those are the two solutions, the two numbers you can put in for x and have this absolute value equation be true. Number 10 says the absolute value of x plus 17 equals negative 3. But when you see that negative number over there, you know there's no solution because absolute value of anything can never be negative. And for number 11, now the way things are now, the absolute value part is not by itself on one side. So we need to fix that first before we do anything else. Leave the absolute value of 4x minus 1 where it is, but subtract 7 on both sides. So then it says absolute value of 4x minus 1 equals 11. Now that we have the absolute value by itself, we can break it up into the two separate equations. Four x minus 1 equals 11, or 4x minus 1 equals negative 11, and then solve each of those. So add 1 to both sides, we get 4x equals 12, or 4x equals negative 10. Then divide both sides by 4, and we get x equals 3, or here x would be negative 10 over 4, which you could either write in fractional form. In lowest terms, it would be negative 5 over 2, or in decimal form as negative 2.5. I'll do the rest in the next part of the video.